people to get in, and then so you can start right at 1 o'clock.
So now it says it's broadcasting. All right.
And people are yep, you'll see people start to come in the attendee list now.
Where's my, okay, I just closed the attendee list. Participants, yes. Okay, very good.
Okay, this is Karen, and I'm just to welcome everybody to the BayesMap Solutions Vendor Spotlight today. Andre will be your host, and he will take it over from here.
Thank you. Good morning, good afternoon, good night, wherever you are. Thank you for connecting to this vendor spotlight. So I'm gonna start right now. Maybe wait another minute or so. So everybody's here.
Yeah, it's just 12:59, so give it another minute. Okay.
Okay. Hello, everybody. My name is Andre. I founded BayesMap Solutions about 6 years ago. I'm a research scientist. I come from the academia. Now I develop custom software solutions for the LiDAR industry. My background is in image processing and LiDAR waveform processing using probabilistic techniques such as Bayesian inference. So I chose the name BayesMap because of the Bayesian inference. You'll see what I mean by that a little bit later. So our goal at BayesMap is to offer custom processing solutions to help you improve the quality of your laser scanning data. So what are the advantages of the BayesMap software? Well, it's a very simple way of using software. It's just like Glass Tools, command line, easy production integration and batch processing, fully cloud compatible. I'll show you a few examples. Multi-platform. And we implemented the software to be extremely efficient, optimized for multi-core. You don't even need a GPU. All the packages are standalone, they're independent. You don't need a platform or anything special. And we offer a free 30-day demo. It's fully functional. So you can try all the features before you buy. And the software is sold as a subscription. So there are quite a few advantages of getting a subscription. The licenses are floating, they're very easy to use and share between computers or users within the same group or company. There's a dedicated email support from the developer, which is pretty rare in general. Fast lane available for people who want an answer within a business day or so. There are 5 to 10 hours consulting or testing included in the yearly subscription. And because we consider that the success of BayesMap is tied to the success of our clients. So we're trying to help you solve problems that pop up randomly, such as bad data, faulty sensors, or anything unusual that can happen. Just send the data over and we'll look and help you set up the command line if needed. So we have different types of subscriptions available. We have many discounts for academic use, I mean, research and teaching, or also low volume users, people who just want to use it for a month. And we have environmental discounts as well. So included in the subscription, of course, there are updates and bug fixes, but also the big new features and also possible feature requests. We got quite a few feature requests now from all the clients, and we try to implement them as fast as possible according to a priority. We also have a few resellers, and we are working to get more resellers. So we have one in USA, LiDAR USA, and one in Japan, OPT Technologies. With resellers, we have a tiered pricing for the most expensive UAV platforms, the cheaper UAV platforms, and also for Airborne. All the updates are, of course, included, but there's no feature requests. Here, there's a reseller support available. And extra support or consulting can be purchased from BayesMap if needed. So we have been in the cloud for 2 years now, and things are developing really fast. So since 2019, we have had clients working to put the software, all the software, both StripAlign and WavEx, in Amazon or Microsoft clouds. And usually we have clients with pools of 10 or more licenses, having an unlimited subscription. And they process large amounts of data in the cloud. It's easy to use because it's multi-platform, so you can choose the Windows or the Linux version. And it's ideal for large or very large companies across multiple locations to share data and to collaborate without having to transfer files and do complicated stuff across workstations. And now, coming soon, StripAlign will be available in the Rock Robotic Cloud Marketplace. So it's a platform for UAV data where you can do a lot of things. You can run jobs like classification, extraction, measurement. And so, as they say on their website, processing tokens allow you to get professional deliverables from your point clouds. And one of the deliverables is actually StripAlign. So you click, and then you get your data aligned for you, and you just pay for that particular job. So that's coming soon, a little bit later this year. So now I'm going to focus on the BayesMap software. So the two main available software right now, which are WavEx and StripAlign. So we use Bayesian inference. Bayesian inference help use all the available data and all the prior knowledge in an optimal way, in a probabilistic framework. And the goal is to improve the accuracy of the data and at the same time help you reduce collection costs. So first, I'm introducing WavEx, the main features of WavEx. So this is software that extracts points with attributes from waveforms, from raw waveforms. So currently it works with Regal SDF waveforms. In the future, we'll add functionality to import pulse waves and other formats, but now it's mainly working with Regal SDF. There's a single pass, very fast decoding, processing, georeferencing, and last output, all in a single pass, all in a single command line. It's very simple to use. Automatically, it solves for MTA. I would say some clients say that it's better than the existing software or bundled software. It also performs channel fusion, pulse ordering, false alarms, and crosstalk filtering. And most importantly, it estimates uncertainty, which other software don't do at all. So you come up with a range uncertainty for each point. And also thickness, amplitude, and other interesting attributes that you can use for improved classification. It also performs fast outlier filtering and basic corrections, IBRC, atmospheric. And recently we added a feature to export pulse waves for people who want to look at waveforms and keep the waveforms in a friendly format. So this is an example of the framework to work with WavEx. So you start with waveform data, then WavEx does Bayesian waveform processing, extracts optimal echoes from the data. Then you do a gridding, and with a future software from BayesMap, you'll be able to generate accuracy maps, so spatial accuracy maps, thanks to the uncertainty that's being estimated by WavEx for each point. And this is also extremely useful when you want to do change analysis and change detection. Here, a few examples of outputs from WavEx. So this is the corrected intensity, calibrated intensity. This is how it looks like. There is also pulse width export and the target thickness. That's very helpful for vegetation classification. And the pulse deviation ratio, which is an indicator of the pulse shape. And also the most original here is the range uncertainty that you can see on the bottom right. So now I'm switching to StripAlign, our flagship software product. And this is a software that's taken a few years to mature. And basically what it does, it aligns swaths of data of point clouds using trajectory and attitude information. So you can have tens or hundreds or even thousands of flight lines, put them all together or use them in blocks and run StripAlign, and it will align everything for you automatically. Of course, it has lots of options because there are lots of different instruments and different possible configurations, but default options are meant to help you use the software in a fully automated way and very simple. So what are the main features? So time dependent and very high frequency IMU drift corrections. So this is really important for most of airborne data. Also integrated in corrections, you have bore sight and internal distortion calibration automatically, because this is really important. There's always bore sight errors, even when you calibrate your data. So this is fully integrated into StripAlign. You can also use the StripAlign software just to perform bore sight calibration as well. There's a multi-channel capability that can split data automatically for UAV that have multiple beams. There's no filtering required. It's robust to outliers, vegetation, temporal changes as well. You don't need to extract the ground first. You can just put whatever data you have there. And it's very fast compared to ICP or plane or feature matching. It doesn't need any particular feature. It uses all the data except the very rough areas, but it uses most of the data available. It doesn't need built up areas or targets or anything like this. Outputs a lot of advanced QC maps and rasters, and also uses GCP to improve the absolute vertical accuracy. So it accepts LAS formats, and for position and orientation data, all the major vendor formats, including ASCII, which is very flexible. So StripAlign 2.0 was introduced in 2018 and was able to handle any geometry and topology. So here an example of two blocks and cross lines crossing at various angles. There's no restriction. The first versions were a little bit simpler and they required all the swaths to be parallel. So we lifted that restriction with version 2.0. And then you could put pretty much any type of data in there. So now I'm going to focus a little bit on the new features. I mean, some of the new features, because there have been lots of them added along the years. So UAV and Sonar compatibility has been improved, greatly improved for the past 2 years. And so now we are able to propose StripAlign for UAV. It's not totally official yet because we still want to incorporate a better registration algorithm, but the existing one already works very well. That's what our clients say. I'm not saying that. And also recently, within the past year, we've been working with Sonar. And it turns out that under certain conditions, it can also align Sonar data pretty well. We worked a lot on improving processing for very large data sets, and especially for corridor mapping that can be very tricky because of the lack of overlap sometimes. We also added support for WKT and many projections and geoids. And better robustness to temporal changes, because that's something that happens. You want to align data taken different months, different years, different seasons with different water levels. So this works out very, very fine now. So if you want more features, there is a Google group where all the updates are listed in detail. And there are many other updates, many other features. I'm not going to read all of them, but you can go and find them in the manual or on the Google group. So here's an example, a graphic example. Original data, no correction. So that's Airborne from the city of Lyon in France. Original data, no correction. This is with internal calibration only, so there's no time-dependent corrections at all. And you can see there's still a lot of IMU drift. There are a lot of errors left. And once you enable all the correction, then you get 2 centimeter RMS relative error, which is pretty good compared to what we started from. And for 2 billion points, 300 square kilometers, the processing time was less than an hour on a small PC. Here, a feature highlight that's been added more recently, corridor mapping. So these on the left, you see overlap maps showing the topology of corridor mapping with very few overlap areas and very long swaths. And the problem here is to obtain data that are have a good relative accuracy, but also a good absolute accuracy at the same time. So that's quite a challenge. And we developed a no drift constant component option that solved all the problems that were at the time. And so the corrections were extremely small, and the control points were used to assess the accuracy. And the absolute accuracy was just a few centimeters at the end for the entire project. Another highlight that is being added in the new version right now, the new version is being released in April, it's the blend feature. So here, a client had a problem with a very, very nice instrument that's otherwise gives really good data, the Optec Galaxy Prime with Swap Track. And probably because of the very large FOV and roll compensation feature, and for some of the swaths, 4 or 5, there were big problems on the edges. There are huge distortions, up to 50 centimeter amplitude. And these cannot be corrected with a rigorous correction with LiDAR equation. There's something else that's not really well understood. So you can see the difference between the original data, the autocorrection. It's not bad, but in the autocorrection, there are still many artifacts left on edges. After the blend feature has been used, the results are very good. So for this particular type of incident, it works very well, and the relative accuracy is very good. The absolute accuracy is just the same as the one from autocorrection, but it takes care of all the residual distortions. Now I'm going to share a few clients and collaborator success stories. I'll show a few large-scale airborne datasets, also some glacier topography that's really exciting, and UAV LiDAR alignment examples from different platforms, some topobathymetry example, and also sonar. So here, the first airborne dataset from Merrick. It's a typical example of about 12 billion point, 60 spots, 15% SciLab. The processing time is given here. Doesn't mean much probably today because that was done 2 years ago. On a small computer, basically it takes about 3 hours processing depending on the task. The most difficult part is the registration, the point cloud registration for that type of data. So 300 gigs of data takes about an hour. So here, this is the point density image. So all these rasters that I'm showing are from StripAlign. StripAlign generates that automatically. This is the point density image. It shows the density and the two cross lines that were used. Here, another output from StripAlign is the hillshade QC map. That's very useful to visualize the terrain. In some cases, for some of the clients, it's very useful also to visualize misalignments, especially horizontal misalignments. They show up really nicely on that kind of map. The roughness map is nice to look at. It might have some interesting applications. It's mostly intended to show where the areas that are extremely rough are located because they're removed from registration. So if you have 90% forest, there might not be enough information for registration with the current algorithm. So that's the main purpose of this map. It also helps visualize the roughness of the data. For instance, when you have UAV data that's a little bit fuzzy, you can assess that fuzziness with looking at this roughness map and see the improvement before and after alignment. The Z difference map before correction. So here the scale, the color scale is 25 centimeters. So in some areas, it wasn't very good. And after correction, 1.5 centimeter RMS residual. So that met the quality criteria for, I believe, quality level 0 or something like this, especially after vertical bias reduction. Another example here of a large airborne data set is from Surdex, also using Galaxy Optic. So when you have very, very large data sets and collects that span across multiple months, the idea is to use one big collect and to align it and then use it as a reference and align the next collect on top of the first one. So that's what they've been doing for 3DEP. Here, that's an example for Nebraska. So for this particular project, it's about 70 billion points. So it works really well. If you don't have too many blocks, it's pretty much the same result as aligning everything at the same time. So that's one of the major features of the software. So you can do it incrementally rather than reprocess the whole data set every time you add a few new flight lines. So still in the topic of large-scale airborne surveys, NEON has been using both software, WavEx and StripAlign for a year now for processing to get better results, so better waveforms and also better products and attributes. So they extract the point clouds and also pulse waves files with WavEx, and then they align both LAS files and pulse waves files with StripAlign before processing and distributing their products. That's a very interesting example of topographic elevation change here. This is from UNBC using many observations for a few years. So that type of work, that's a tremendous amount of work. It requires the data to be very well aligned in order to be able to compare data sets and measure change in glaciers. So that glacier lost 1.5 gigaton of water and in about a year. So to measure that, they had to align the data with StripAlign very carefully. And now they're reprocessing the data using WavEx to get better echoes and to solve some of the MTA problems that they have in some areas, and also to get an uncertainty layer so they figure out which areas are more reliable and where the changes that they measure can be trusted. Now I'm switching to UAV. I have 6 minutes left, so I'm going to speed up a little bit. This is TrueView 515 data from GeoQ. If you saw the presentation yesterday, probably familiar with it. So just a cross-section example here, before and after alignment with StripAlign. So the horizontal error has pretty much disappeared, as you can see. But what's really interesting with StripAlign here is by splitting into multiple channels automatically, you can also perform the multi-channel calibration and recalibrate all those beams, or at least groups of beams, in such a way that the precision is improved. So this is a cross-section of a rooftop before and after alignment. So you can see that the fuzziness has been much reduced. There wasn't much fuzziness to begin with, but it's even better after alignment. Another data set here is from Rock Robotic, from LiveVox mid-40. So this scanner has a really fancy scanning pattern. It's kind of odd when you come from the airborne industry. But anyway, so it works pretty well. You just need to fly slow, and then you can sample a lot of points, get a very nice point density. And here, even with this weird pattern, StripAlign did a great job at correcting the data. So again, about 2 centimeters RMS after correction, relative error on this data set. This is without splitting. This is just a very quick and simple automatic test. Here, another UAV data set. So this is from Martin Isenborg in Samara. So he said you should go and visit him and his laser chickens. So this is part of a collect that's going to be used for mangrove restoration. And I'm showing the QC maps from Martin. These are not mine, just so you show that there's an independent validation here. So before and after alignment, so the errors have been very much reduced. So this is a GeoSun, relatively cheap LiDAR system. And the errors are quite large to begin with, about 50 centimeters horizontal. They're quite significant. They're reduced very much after alignment here. I don't have the exact numbers, but you can go and you should go and read that blog there. It's really interesting. And there's another example in the blog that I don't have time to show today from a different data set, also in Samara. And another example, this is from Japan. It's from the OPT website, our Japanese reseller. So that's another example of UAV application. You can see the flight lines here and the before and after alignment. It's also an affordable system that has some significant errors before correction, and the correction is quite spectacular in this case. Another interesting data set here. This is a topobathymetric data set. That's from a few years ago, but I wanted to show this because it's quite unique. It's a topobathy LiDAR system, and at Airborne Research Australia, they worked really hard to collect that data, and then they aligned it with StripAlign. which from left to right, you can see there is an improvement. It's much much sharper. You can see the reef much better with strip alignment. So the full article is available in GIM International from 3 years ago, 2017. And here I'm going to end with this Sonar data set. So Guardian Geomatics collected this data with AUV multi-beam sonar system. And so underwater, the problem is that horizontal location is quite a problem. So there are very large horizontal errors to begin with. That's just the way it is. So you can see these errors and how they're reduced from left to right using strip alignment, especially on the example on the right. You can see very, very large displacement between these two swaths that are reduced. And these are height maps here. So you can see how the height maps match one another after alignment. So now I'm going to talk a little bit about software and feature availability to finish up. So released in 2020, available right now. So WavEx 1.2 and StripAlign 2.18. Coming soon in April, StripAlign 2.19 with new features, the blend features that I showed today, the UAV automatic cut. So when you have a single file and want to cut it automatically into multiple flight lines, now StripAlign can do that. GCP improvements and features related to control, and also a better caching mechanism. Later in 21, we're going to add new features. So some reference data optimization and client requests. That's in 2.2. In 2.3, we will introduce our brand new registration algorithm with full UAV support. And in 2.4, we will have a graphical user interface that will be multi-platform, mostly for people who've never used the software. That's going to be really, really easy to get introduced to the software features, and it will still be compatible with a command line, of course. And then we will also update, towards the end of the year, we'll update WavEx to accept RXP waveform from Regal. And so it will be able to process more modern sensors than those that currently output SDF files. And what about the future? Well, we have a ton of planned and requested features by our clients. So there's cornrow and noise filtering that's planned at some point, a pulse waves input for WavEx for academic projects. And also we have had requests for distributed processing for StripAlign for very large scale deployment. And trajectory-free correction that would help people correct their data even if they don't have trajectory. That seems to happen more and more, or sometimes data are very weird and they're damaged, or there's some missing information, and the only way to correct is without the trajectory. And future software, you can see more on the website, but there's accurate gridding, ground filtering, uncertainty, output. Yeah, so that's really interesting for next year, and also automatic cloud change detection. So registration and change detection, we might be able to get that done later this year. So if you want more information, there's a website. So feel free to email us at BayesMap. And see you next year in Denver, and bring your own data if you want real-time testing. So thank you for watching. I'll try to answer your questions offline. Thank you again.